naked, I'm numb, I'm stupid, I'm staying. And if Cupid's got
Hello, and welcome to the Concepts video on graphs of linear functions. So there are a couple of ways to graph a line of the form y equals mx plus b. So the first way would be to plug in the range of x value, or a range of x values, so various x values, and then figuring out what the values of the functions are at each of those inputs, and then plotting each of those xy points that you find in order to make your line. Or there's a second way, which I like and is a little bit less tedious, but basically you utilize. So what we're going to do is utilize our b, our y-intercept, right? I'll abbreviate. So our y-intercept and our m, which is the slope, in order to just graph our line, get 2 points maybe, and then just draw it, okay? The thing is, for a line, because the rate of change is constant throughout, once you find 2 points on your line, you just draw a line through them, and that's it, right? Because 2 points define a line, okay? So let me show you an example of how we can graph a line. Okay, so here's a function we can graph. So f of x is equal to 5 minus 2 over 3x. I'm just going to rearrange this to say negative 2 over 3x plus 5. That way we can kind of clearly identify which ones are m and which ones are b. So m is equal to negative 2 over 3, and b is then equal to a 5. Okay, because you can always check this by plugging in 0 for your x, and then whatever's remaining is your y-intercept, or basically your y-intercept. Okay, so this is the first thing we're going to do. Because our y-intercept means that y of 0, or f of 0, let's say, so f of 0 is equal to 5. So that means we already have 1 point that we know, 0, 5. So let me draw a graph here, okay? We'll just draw x and y. Let me draw a more horizontal looking x-axis. There we go. That was a little bit better. Okay, so we have 1, 2, 3, 4, 5, 6, let's say. So 5, 1, 2, 3, 4, 5. There we are. I'll just label a couple of things. Okay, so we know the point 0, 5. So that's where we start, okay? And see how that point is on the y-axis. That's why it's called the y-intercept, okay? And then we used our y-intercept. That's good. And then now all we have to do is use the information given by our slope, okay? So this one here, there are a couple of ways you can interpret the slope. So you can say, well, this is negative 2 over 3, which would mean as you go down 2, so down 2, as you go to the right 3. Okay, so let's draw that. So down 2, so we're going to go down to 3, and then over 3 units. Okay, so it'd be like this. Alrighty? Conversely, what you could also imagine this as is the following. So we could say, well, the negative actually belongs on the bottom. It doesn't really matter. It'll give you the same thing. So 2 over negative 3 would mean, well, the rise would then be up 2, and this negative means left 3. Okay? So like I'm showing you, it's a couple different ways you can think of things. Right? So this is like 7. So up 2, so we'd go up to 7 in the y, and then to the left 3, so to negative 3. So like over here. See how in both directions, the points that I drew, they're on all the same line, right? So it doesn't really matter which way you interpret it. Okay? Alright, and there it is. That's our line, okay? Alright, so here's another example. We'll do an exercise here. It says match each equation with one of the lines in the graph below. So here in the graph we have 4 lines, okay? And here we have 4 equations in order to match them up. So let's just identify for each of these what's the slope and what's the y-intercept, okay? So for f, this is going to be the slope is 2 and the y-intercept is a 3. Okay, for g, the slope is also a 2, but this time the y-intercept is a negative 3, okay? For h, we have the slope of negative 2, but a y-intercept of positive 3. And for j, lastly, we have slope of 1/2. That's a little bit different, right? And a y-intercept of positive 3. Alrighty, so now let's look at our lines. So we actually only have one that crosses the y-axis at negative 3, right? All the other ones cross here at positive 3. So this negative 3, because it crosses there, that means our y-intercept for this line should be negative 3. And if we look back at our information that we found, the only one with a y-intercept of negative 3 is this guy. So this one, this line down here, has to be our g of x, okay? That's the one running along on the bottom there. Okay, so now let's look at the other one. So everything else has a y-intercept of 3. So let me cross out the ones we've already done. Okay, so we did G, and now everyone else has a y-intercept of 3, so that doesn't help us distinguish one line from another, right? So we have to look at the slopes. So let's look at f of x. So now the slopes are all different, right? This one's positive 2, this one's negative 2, this one's 1/2. So first of all, let's interpret the 1/2 one, okay? Let's look at j of x. So 1/2, a slope of 1/2 means you go up 1 for every 2 units you move to the right. So if from this point we go up 1 and 2 units to the right, we're here, right? Or this could also mean you go down 1 for every 2 units you move to the left, right? Because then those negatives would cancel. So you go down 1 for every 2 units you move to the left. So see here how we found 2 points on our line? So this line here, this one that I'm kind of tracing over, this one must be the one corresponding to a slope of 1/2. Therefore, it must be our j of x. Okay, so that's that line. Got 2 of them out of the way and 2 more to go. So let's look at 2. 2, that was very general. Let's look at f of x with a slope of positive 2. So that means for every 1 unit we move to the right, we have to move up 2 to get to our graph. Okay, so from here again, we'll go from the y-intercept, right? So we go up 2 and over 1, so that takes us to right here, or we could go down 2 and over 1 to the left, and that brings us here. And we see that this line that I'm tracing right now does have a positive slope, right? So this is our f of x. And so the last one, the remaining one, has a slope of negative 2, so we just have to make sure that that is true. So we start from here, our y-intercept, and we go down 2 over 1, and yes, it takes us back to our graph. So this last one must be h of x. Okay, and we're done. Okay, so now let's go over intercepts more in detail. Intercepts. Okay, so notice I have the plural, which means not just the y-intercept. So what we have are actually, technically, they're called vertical intercepts. So vertical intercept is basically your y-intercept, the one we all know and love, but at this point, our b, right, for our linear equation. So this is when x is equal to 0, right, when our input is equal to 0. On the other hand, we also have what's called a horizontal intercept. Horizontal intercept here. So this is our x-intercept. When our function, or when our graph crosses the x-axis, so that would be when the value of our function, when our y is equal to 0. Okay, so it's kind of an opposite thing. The horizontal, when it crosses the x, that means y is equal to 0. When it crosses the y, then that means our x equals 0. Okay, so let's do kind of a little exercise. So we're going to find vertical and horizontal, I'll just abbreviate, and horizontal intercepts of, and I'll give you guys a function here to kind of play around with. So f of x is equal to 3x and then minus 2. Okay, so for a vertical intercept, we just have to see, so we just set our x equal to 0, right, for vertical intercept. So when x is equal to 0, we get f of 0 is equal to 3 times 0 minus 2. So that means, I guess it's a negative 2. Okay, so this would be our b, essentially. So this is our vertical intercept at 2. Well, that would be like 0, comma, negative 2 is the formal name for that point. Okay, and then now let's find the horizontal intercept. So this would be, when does our function equal to 0? So I'm going to write out our function, and we're going to set it equal to 0. And then we just solve for x, okay? So now we take this guy, and we solve for x, so we get x is equal to positive 2 divided by 3. Okay, so the point representing our horizontal intercept would be 2 over 3, comma 0. Okay, and there it is.